All right. Well, first of all, thank you all for coming and thank you for inviting me, Jack. Before we begin, Happy New Year to everybody. It was a great year, 2019, and 2020 should be even better, at least because the number is nicer and rounder. My name is Art Linkov. I'm the co-founder and chief scientist at NeuraLegion. If you haven't heard about us, we're a full crystal in production company. We're doing cybersecurity, specifically application security testing, using lots of AI and cool buzzwords in this domain. Um, a little bit about myself. My name, other than being, very busy with the startup, I have some time with doing some open source shards. The main, I think, most known shard is Shined. It's a machine learning shard for deep learning, neural networks, convolution networks, etc. I am formerly a biologist. I had my master's degree in biology and molecular biochemistry, but since I was always, in love with writing code ever since high school, kind of the world of biology and code kind of led me naturally to machine learning. I have 7 years of data analysis during my research and both big and small data. And to be honest, I just love G sheets. I love analyzing data, playing around with it. Bar, my good friend and CTO who's with us can attest. I've spent many an hours customizing my D&D sheet on on my Saturdays. All right, so I do want to say my sincere apologies before I begin to all those shards that I missed. I tried to do as thorough review as I can um, to kind of capture the current state of AI in Crystal. But if I did miss someone, it's not because I think that your shard is not good. It's just that I'm a simply one person. And I will share this presentation later. So if you feel like you want me to add this shard, please send me an email and I'll just add it and send Jack the presentation later. So when, when Jack approached me and said, I want to do a presentation about AI, are you up to it? I said, yeah, awesome, great idea. But then I kind of thought about it for a minute and said, hold on, about AI, about all AI in one presentation, it's a bit much, I thought. And it's just that AI generally, it's such a huge field, not only because there's different implementations and use cases that are all under the AI umbrella, like machine learning, NLP, image processing, all those things. There's also a big skill set of things that are necessary or very big part of doing AI. Things like data analysis or algebra or maths and many, many other things. So to capture the whole thing in one presentation is simply impossible. So instead, I kind of thought about what would I want to hear from a perspective of Crystal. And I thought that a good way to kind of present the current state of Crystal would be to just talk about my personal experience in doing a machine learning project in Crystal, which is aimed for production. And everything that we went through in this kind of project, kind of hopefully to demonstrate where Crystal is now. And I'll do a bit of overview of libraries and things like that later. But let's just jump in. So generally speaking, an AI project or a machine learning project is pretty similar to any coding project, with one major difference is that you don't necessarily know the correct implementation when you begin. You know that you want to do something, you have an aim, you have a goal to solve some sort of problem. But when we're talking about standard projects like building a web server or an application, there are certain practices and there are certain things that are established, and you pretty much know what you need to do. Even if you don't know exactly the nitty-gritty details, you still pretty much have an idea of how your architecture would look like, which libraries you're going to use and why, and things like that. In machine learning, it's a bit different because even if you think you know, you're probably wrong, because you're always learning. You're kind of guesstimating how your model would look like, but you don't really know all the hyperparameters. There's this certain element of uncertainty, of this black boxness that is intrinsic to a project like that. So I would say there's like 3 stages to a machine learning project. The first, of course, is to collect the data, process it, and prepare it for a model creation. And this is a challenge in itself. A model is only as good as the data that you feed into it. Then we have this next stage where you actually want to deploy this into a application environment. So from the perspective of a company like ours, it's critical not just to have a cool model that works in the lab, it also needs to be able to fit production environments and how it's interacting with the application. And there's other problems that arise when we're talking about large scale, which are pretty much the same as any application that you deploy when you need to scale it up. So it's not AI specific or anything. So with that in mind, I want to discuss this project that we did, which was, its aim was to analyze parameter names and try to understand the context of these parameters. So since we're an application security testing company, it gives us a lot of benefit to understand the parameter names and their meaning, okay? Not just kind of blindly automating things, but actually understanding that the word user and the word username, it's the same word, and therefore we need to treat it the same. So for a human, it's easy to understand because we understand the context of the situation, but for a machine, it's a bit more tricky because it's a different word altogether. So we chose to use natural language processing techniques like word2vec, and that was the original assumption, kind of the educated guess that this is the type of technology that we need. We did know, though, that we have a few requirements from this project. The first one, that we needed a lot of parameter data, real world relevant data, not just some invented, I don't know, generated data. We needed the model to be agile. We're a cloud-based company, so we needed to be able to deploy fast and kind of test it and change it in a very agile manner. And of course, even from the beginning, since we're aiming this towards production, it's not just a for fun project at home, we also need to consider scalability, which can be contradicting sometimes between agility and scalability, but we tried to find a balance for both of these things. So let's start kind of through the whole process, and I'll try to illustrate what we thought and the challenges that we faced during this project from the perspective of a company that wants to do everything in Crystal. Okay, so if there's something I really can say that we're really proud of, is that everything that we can do in Crystal, we try to do it. It's like a personal objective of ours. We really love Crystal and we really want to push it forward. So, and obviously it works for us for the reasons I'll mention a bit later, for the advantages that Crystal gives us. But if we can do something Crystal, we will. So starting from the data collection, we wanted to use a crawler and browser automation to collect data. And we needed to improve existing libraries because the ones that, that were out there were not fully compatible with what we needed. So we needed to spend some time on that. In regards to labeling the data, we just used our own proprietary technology that does that. So it's not something that was kind of off the shelf, but it was okay with us because that's actually what our product does. And and here comes the kind of the breaking point, the sad part of the story. So when we began this project, I was really passionate about really kind of having a great NLP project in Crystal, and we tried using Crystal libraries, but unfortunately they were not production ready. Now, what does it mean to be production ready from our perspective? So when we're talking about a library that needs to go into production, especially something that is kind of complicated to grasp or even impossible to grasp how it works within, okay? Machine learning has a lot of black box kind of inside of how the model works. Nobody knows. You just know that you put some information on one side, it does some magic, and then put some output that you're expecting. And there is a certain element of you need to trust that the library is going to serve you well in production. And when we're talking about more mature libraries, we know that they have been very thoroughly tested in regards to the nitty-gritty details, where they don't crash because the location of memory is kind of wonky, and they're very optimized by a lot of trial and error. The math is very stable. Sometimes the math can also be problematic, even if in one library they decided to use this randomization algorithm, and in the other library they decided to use that one. These things matter in terms of the machine learning library that you're using. So I remember talking with Bar, listen, I'm really bummed out. I really wanted to make a good Crystal library, but it's just going to take months to fully test everything, to fully build and improve the existing libraries that there are there. So unfortunately, we had no choice to turn to existing libraries like Python libraries and kind of build the model itself around it. So, and that's what we did. And I don't know if any of you have ever tried to kind of run Python and Crystal at the same time to communicate together. Let's just say that when we try to kind of create an inter-process communication between Python and Crystal, it did not go well at all. So instead, what we did was to containerize the Python code and kind of wrap it into this small server, small REST API kind of server, so that the code and everything else is written in Crystal. So the code between the model and pretty much the product is communicating via REST API. Are there any questions so far, by the way?
Have you seen the Python or the Crystal where you can like launch a Python interpreter like in Crystal, like basically the C API?
Mm-hmm. I think that it wasn't very mature when we were working on this project. Right now, at this point, I would definitely try it out if I could. That ship has sailed a little bit, but still, we're always figuring out ways, to improve that. To be honest, and that's kind of like a silver lining for that, is that because we built the whole model in kind of a black box way, we can just swap it out later, and whenever we have a better library in Crystal, for example, which is more efficient or works better than the Python library, we can just replace it. So that kind of forced our hand to do it that way. Now, in regards to monitoring, verification, first of all, I know it's not a new concept, but you have to collect logs of everything. You have to start anything that happens in the system, collect logs. The model is starting, the model is training, this parameter was inserted, this output was, you got out. You have to log everything, especially in a situation like this where we have two different languages communicating. You have to be very thorough in what the information that you're putting, but that's obviously not something new. It's also very important, and that's generally speaking in machine learning products, to always collect more data, because as I mentioned before, all you're doing when you're in the research phase, you're kind of guessing what would be the best model. But as you're collecting more data and you discover more real world scenarios, you realize that there are some cases you didn't account for, or that your original assumptions were not, didn't catch all the real world scenarios, but they were more relevant to a smaller subset of the data. So that's always something that you need to do, and that's very easy to do, especially if everything is automated. Regarding testing the model, well, it's not that difficult if you know exactly what you're expecting. So you can build your benchmarks, you can constantly use the logs and the data to improve your model. And finally, when we wanted to keep in mind the scaling up of the project, so as I mentioned, the fact that it was the Python code was containerized and kind of as a separate unit, it just means that we can swap it. And we're really eagerly waiting for the moment where we can just say, yes, everything is in Crystal, no more Python code in our machine learning. All right, so I really tried to kind of condense all of the experience that we got while we were working on this project. And I really hope it kind of conveys the message that Crystal is in a very good place right now in regards to stability. When I'm not talking about AI, I'm talking about generally. We mentioned the Lucky framework a little bit before the presentation, and there's a lot of things that are going very well for Crystal, and we're using Crystal in production for 2 years now, and we're very happy with the stability and the performance and everything. So it's not a problem of Crystal. It's just a matter of improving the libraries and investing a little bit more time in polishing the things that are already there. So with that in mind, I kind of wanted to give like a shout out to all these libraries and all these developers out there that did a lot of good work on various aspects of useful shards that are going to be relevant for you if you want to try a machine learning project, from NLP to database management and things like that. So this is the list, and again, please, if I missed someone who deserves credit, please let me know and I'll add their name happily to the list. I kind of at the beginning thought that maybe I'll have some time to go through all these libraries and kind of dive into the good and the bad, but I decided against it, first of all, because it's going to be a little bit unfair for the developers, and second, it's just going to be dry and boring. So if anybody has any questions, I do have some experience with these libraries, with not all of them, some of them, so just reach out and, or even better, reach out to the actual person who made these libraries and maybe even contribute. Why not? So, and this is my favorite part of the presentation. Honestly, I was waiting for this slide from the beginning. So why do I think that Crystal is great for AI? Well, first of all, and I cannot stress this enough, I have not yet found a language that is easier to read from the perspective of syntax and the way the language looks like. And in short, I can just, if I can forget about all these reasons, if there's only one thing that you can take out from this tonight, is think about it this way. Machine learning, AI, all these fancy algorithms are complicated and complex enough on their own. All the math and all the vagueness of the algorithm, they're complex on their own. And it has been so many times when I was looking at code in, for example, and I found myself pulling my hair out, trying to understand what is going on there. I mean, there are some very smart algorithmicians writing some code and naming parameters alpha, beta, gamma, theta, and all that. And just, it's very difficult to read. And that's something that I feel like in Crystal as a language is very helpful in clearing your mind to focus on the complexities that you should be focusing on, like the actual algorithm and not what is written here. So native compilation, of course, better for performance than scripting languages. That's not even a debate. Another thing that I'm not sure that people take into account, but we enjoy it very much, is the test-driven development nature that Crystal has. I'm talking about the built-in specs and benchmarks. It goes very well with scientific methodology, with the fact that you design some sort of test, some sort of experiment. You have an input and an outcome that you expect, and you can build hugely complex architectures and algorithms with these in mind very fast, because it's very natural in Crystal. Well, we kind of talked about it a little bit, but honestly, amazing error reporting when I'm writing some code in some other languages and I get an error like syntax error or that data type is not good. Okay, but it doesn't really help me to solve the problem. And really, I think Crystal has amazing error reporting in that regard. It really forces you to kind of understand what you're doing and gives you the information that you need to solve these problems. Multi-threading is great, because why not? The building doc support to transfer all your code into a documentation with just one command. It's really awesome. It really helps out when you're doing any kind of projects, really. And the last point is really kind of my own personal opinion in regards to strong types. I know that many people who are used to Python or Ruby will not agree with me in regards to having strong types, that it actually helps. I feel like it really, really helps out with readability. I'm not just talking about all the benefits that it gives you with the compilation of your program, where it just doesn't run if you have a problem, but from the readability perspective, where instead of having a parameter that's called alpha and some value of some other parameter, here I actually know exactly what type of data goes into that parameter and what happens with it. I know that this is an array of array or a matrix, so it really helps me to keep myself focused and understanding the code. So that's just a personal opinion of my own. You don't have to agree with that. If there is anything that you feel like I forgot, just feel free to let me know. Okay, so we've talked about the good and the great, and let's talk a little bit about what we can do to make Crystal even better and more AI friendly. So after really going through the libraries that we have out there and trying to kind of understand their maturity and where they are, I came up with this list. So first of all, in order to have good AI support, Crystal must have better math. Right now, there's not a good stable n-dimensional array library like NumPy. And that's pretty much the backbone of machine learning AI in all modern programming languages. It will really, really help to have better statistics and advanced math libraries, things like different randomization algorithms and distributions and things like that, that are really kind of trivial for more mature languages and are a little bit missing in Crystal, because there's not a lot of people who use them outside of AI, or maybe some statistics or research. And Crystal is a growing community, so we need more of those. Better data visualization like Matplotlib and Pandas. We have recently started to get new libraries like that, but we do need to make them much better. Other tools that can be useful are image processing or other signal processing formats. I'm not talking just about parsing a JPEG. I'm actually talking about taking it and breaking down the bytes or transferring the pixels into arrays or to do some convolution and filters and things like that that are not machine learning or AI related, but they're very useful and necessary when we're doing some things in AI. Genetic algorithms could be nice. And generally speaking, I think libraries need to be more stabilized and improved, and that's just a community effort. Personally, I think that doing bindings is not a good idea for Crystal because doing bindings for C or Python, it kind of misses the point. I mean, Crystal is a compiled language. It's you don't need to do bindings because the language is in itself low level. There's no need for that. So when we're kind of trying to bind other libraries, what happens is that it just loses the whole point. I mean, ports are great. If you take some library in Ruby and you just translate this code to Crystal, that's awesome. And we need more of those. But that's kind of, again, a personal opinion. What else can we say regarding production readiness? So that's something that is especially critical for companies like ourselves when we need to trust that libraries are ready for production. And some of the ways to do that is other than stabilization of these shards. And the way to prove that this stabilization actually has been done is to create a lot of unit tests to show that every time that there is a new version, there's a new build, it's going through a big series of unit tests, and that's why it's stable. That's why I, as someone who wants this library and put it in my product in production, I can trust that it's good because of all these unit tests. Also, something that is very, very important, and it's to have clear roadmaps in the README or somewhere in the library of just saying, look, this is, let's say it's an NLP library. This is all the algorithms that we have. These are the ones we don't have yet. We're working on, and just so I know what this library offers and if it's really what I need, or if I need to maybe add something or request something. GPU bindings, of course, is really helpful for machine learning related operations, but I haven't seen anything very, I don't know, at all, I think, in Crystal. And the final point is regarding research friendliness. So one of the major drives of AI in general are people who are not thinking about production, people who are just thinking about building cool things and making cool projects, either if it is in their private time or as part of some academic research or some company research. These people don't really, why is Python very popular? Because they don't have a very big threshold on starting and getting results really fast. But that's the thing, Crystal is really easy to write in. If you kind of have a little bit of, you saw a few tutorials, you saw some documentation, Crystal is really easy to write. So I believe that with more tutorials, I'm not just talking about this is how you make an array. I'm talking about tutorials of, look, this is how I built my neural network in Crystal, or this is how I created a dictionary that translates from Chinese to Klingon. I don't know. The second point here is eager mode. It kind of connects to the first one. In many machine learning libraries, there is this kind of thing called eager mode, where you have a very simple API for writing a few lines of code and ta-da, you have a neural network that, I don't know, can separate between cats and ducks or something. And of course, the final point, I really love Crystal Play. I think it's great. It's a brilliant thing. We just need to keep improving it because eventually I'm using it all the time when I'm doing quick, prototyping or quick testing for things. I think it can be done even better. Um, yeah, I feel like I've been talking a little bit nonstop. Is there any questions or feedback from the crowd? I can't really see you. The window is so small.
Yeah, someone was asking about Bottle, and it's Bottle is up and coming in math tensor area. Have you seen Bottle written in Crystal or the Crystal Shard Bottle? And I guess do you have any thoughts on that?
The Crystal Shard Bottle?
Yeah.
I haven't seen it. So if it's one of those that I've missed, so I would be happy to take a look. It's a TensorFlow-like library.
I think the short answer is I don't really know too much. I took a quick peek at it, but Christopher's in the chat and he says it's like a pati, but better. So I don't know per se, but I guess it's a TensorFlow-like library.
Mm-hmm. Well, I'm not, and I'll be happy to take a look at it. So thank you for the suggestion, Chris. I'll be sure to take a look at it.
I don't know if anyone else has any questions. I think those are the only ones from the chat. Oh, wait. Yeah, I think that's the only question. Yeah.
Actually, I have a question.
Yeah.
What is the main difference between machine learning and AI?
Depends who you ask, I guess. I think that the consensus right now is that AI is a more broad definition and machine learning is a part of AI. But I think that some people would disagree. Pretty much today, AI is, as I've shown in one of the first slides, it has under it natural language processing and convolution networks and deep learning and machine learning and genetic algorithms. All that are kind of part of AI, where machine learning specifically is kind of taking big amounts of data, kind of shoving them through some sort of model and tweaking the model parameters until you get the result you want. So I think that's kind of the general vague definition today.
Do you think one of the biggest problems of I don't want to cut you off. Did you get?
No, I'm fine.
I feel like one of the things that slows down adoption of Crystal, or even when I'm using Crystal, slows down adoption of libraries is tutorials and things like that. Do you think that's I know you have it written down there, but is that one of the biggest biggest stumbling blocks when people are trying to get into kind of more of this AI stuff in Crystal?
Yeah, I think so. I really do feel like there's a lot of people who want to start doing machine learning things and AI things, and it's just kind of easier to go to the established languages because there's so many examples and there's so many tutorials, and the libraries themselves are so optimized for newbies that it just makes it easier for them to go with those. And that's why I feel like because of the nature of Crystal, because it's easy to me, I feel like honestly writing code or reading code in Crystal is much easier to me than in, I don't know, Python or JavaScript, for example. And I feel like if there were a bit more tutorials or the documentations were a bit more user-friendly, people would actually choose to go with Crystal because why not? It's easier. The language is nicer. It's faster. I mean, I really do believe that.
Okay, cool.
All right.
You got another
so-
question in the chat.
Oh, I don't see the chat.
The question
Zoom
is,
chat.
what is the biggest roadblock that forced the use of Python component, of the Python component? So I guess it's, what was the biggest roadblock that made you guys choose to use the Python model in your own deployment?
Mhm. Okay, so from a technical perspective, the biggest roadblock that I felt we have, it wasn't even the kind of readiness of the library itself from the perspective of scalability. It was there was not many algorithms within the libraries so that I can play around with a bigger variety of models. So in many cases, libraries in Crystal, because they're relatively new, so they kind of start doing something and they introduce one or two or three popular models, but there's a big list of things that is still missing. So unless I want to work with this specific model, I don't have that in those libraries. And that's an important part of the research, where I still don't know which one of those algorithms is the right one. So I need to test a big variety of them. And obviously, if they're all in one library, it makes it easier instead of having, I don't know, many different libraries. That was, I feel that was the main reason that we chose not to go with Crystal libraries. All right. Well, first of all, again, thank you for coming in and listening to me ramble at 2 a.m. Local time. I really believe that, you know, working on open source is not easy. It's something that really requires people to give from themselves, to spend their own time, and it's hard to do. We all have jobs. But that's something that I really love about the Crystal community, is that it's a really supportive community. It's still young, relatively speaking, but I've never felt like I have a question or something when I'm talking with people on Gitter. Really, the community is great. I've been following the progress of the AI world in Crystal for the last 2 years. I do feel like it's progressed a lot. And I'm very, very eager to see what's going to be happening in 2020. I mean, I really hope that by the end of this new year, I'm going to forget about any other language and do all my machine learning in Crystal. That would be a dream come true to me.
That'd be awesome. Does anybody have any questions, since we have you know, or are you ready for questions? Can you hear me? Are you ready? Would you like any questions?
If I have questions?
I was just going to ask, does anyone have any questions for Art, since we have them?
When you're doing a comparison with Python, what type of Python are you comparing it to? Because there's like Python, there's Numba, there's all these other accelerated Python libraries.
You mean for project-specific cases like NLP or machine learning? What do you mean?
Yeah, you can take the question whichever direction you want it to.
Mm-hmm.
But yeah, just talk about like how you're comparing the performance of Crystal to, I mean, I really want to know, like, is it actually faster?
Okay, so it's a good question. So I think that if we're talking about just the libraries, the Python and the Crystal, Crystal is much better. The performance is better. There's no doubt about it. It's a compiled language. It's not a scripting language. But the thing is, because most of the Python machine learning language libraries, they're working off a C backend kind of. They're wrappers of C libraries. Then the performance of these libraries is very, very well optimized. It's something that's been around for many years and in production. But the thing is, I feel like it's not just about how fast the model trains. I feel like the whole process of creating something in machine learning also needs to include how easy it is to actually do the project, how easy it is to find bugs, how easy it is to find problems. If something fails along the pipe of your data flow, it's really, really tough to do that when you're writing in Python, which is kind of a wrapper of C. I've had friends who were driving themselves crazy trying to understand why their model is not working because there's some buffer overflow somewhere, and they just don't know because this information doesn't go up towards the developer when it runs. It really is tough. With Crystal, if something happens, you can just easily see where it failed. You can just have an error report for that, or just pretty print some of your objects or things like that. So I really feel like maybe the performance of, if you take like the best library in Crystal and compare it to the best library in Python, right now the Python library would win. That's one of the reasons we chose to use that in training, for example. But in the whole process of creating something and working with it, I still feel that Crystal is, at least if not now, it will be much better, hopefully soon.
I have some Python Crystal benchmarks if you want to have me share them. I'm not sure if you want to hand the screen over to me, but I can show you some stuff with that.
Yeah, I would love to. It can really save us a lot of heartache. If you have some, yeah, we'd love it.
I cannot share while you are sharing though.
Oh, I can start the share, I suppose. The presentation is finished.
Just as like some background, I've given some talks on Crystal, the case for Crystal, like just the language in general. I've actually given it here for the 8th Flight University, and I've done this talk. Like it's been iterated on a few times for like different companies and things like that. These execution times and these benchmarks are about a year old. Crystal has seen some performance improvement since then, but this is just the general idea of it. Also, performance, I just put generally, you know, Crystal executions in memory and like so memory usage is more along the lines of like Go, C++, or Rust, and those languages are definitely faster, definitely slower compared to each other or in certain circumstances. But like it's just like in the general kind of like region. It's in the general kind of like you know, like kind of field. And then like with VM languages, a lot of the Python, JavaScript, and Ruby kind of fall into a similar bucket. I have some benchmarks that are specific between Python and Crystal, and these benchmarks were kind of all assembled for Chippy in a talk that I gave at Chippy. So as you can see, execution time in Python, for some of these goes up to 400, 420, and I actually offhanded forget the units, but I'm guessing it's milliseconds. And then for Crystal, you're just talking about like somewhere in like the, you know, single digit milliseconds, and some things will pop up to like, you know, 20 or 25. So that's like the order of magnitude that you're looking in like performance differences for execution time. And this is using the Python standard library. So things like JSON are actually just C APIs. They're just, you know, it's not, Python's not actually parsing JSON. Like, you know, so that's roughly just the overhead of Python on top of the C API. And yeah, so that's just roughly what you're looking at in execution time. I forget the actual X difference, like if it's a 20X difference or something like that, obviously depends on the average and what you're doing, but you can see that crystal in that kind of, that segment, like that range. And then for memory usage, it's a much different story. Well, different. The memory usage for Python is generally over double. So you use twice as much memory or more for Python. Sometimes you use, 30 times as much memory or more, but obviously everything depends on what you're doing. For things like JSON, Python's calling directly into a C API. So that's just the overhead of Python sitting on top of that. And then the Crystal also does that. I mean, Crystal does allocate some memory and stuff like that. So this is just kind of everything from Havelock or Malmut or other things like that, different algorithms. You have some base64 encoding JSON, which is more akin to like a serialization. And then there's Mandel, which I believe was written by Google, or it was kind of referenced when I assembled this to be the kind of what Google uses to rank a lot of languages against each other. So, not as a dramatic difference, but this is a spread of different types of applications that you would or different types of like program types that you would generally kind of put next to each other to see if a language is good at one thing or the other. And this is the difference in memory usage for Python, and this is the execution time. So.
This is a very great illustration. It really shows pretty much why we choose to run everything in Crystal. But you have to keep in mind that for machine learning libraries and machine learning kind of code runs, this kind of overhead that you have from Python is becoming negligible when you need to train your model, for example, for a week, doing trillions of iterations. So because it's running on a C kind of backend, and it's distributed on your CPUs or in your GPUs, eventually it becomes very efficient. Even though the Python itself is kind of wasteful in the beginning, most of the iteration is not in the Python. So Crystal doesn't have it yet. We don't have GPU support. We have multi-threading now, but Python has been optimized around this kind of thing for nearly a decade now. So we're still not there, unfortunately. But yeah, that's a really good demonstration. Thank you.
Welcome. I'll post this talk and put it in the Chicago channel. I have it recorded, so. Yeah, I don't. Do you think it would? This is kind of the end of the talk, but I mean, do you think it'd be a benefit to have a place that people could kind of put specific like AI requests of what we need in like the in the community, kind of like the Crystal community project in GitHub, where people can be like, these are the things that we really need to make Crystal a better kind of target for AI consumers?
Yeah, I think it's a great idea. I even had a thought of taking all these kind of notes and these thoughts that I had and kind of putting in a website where I kind of overviewing AI specifically in Crystal. Yeah, I would be up to doing something like that.
Awesome. I'd like to connect with you later and talk about that and see if there's any help you need and just kind of putting that together.
Yeah, sounds like a great idea. I'm up for it.
Cool. Is there anything else you'd like to say in closing?
Well, thank you for inviting me. It was really an honor to be the first in 2020. I really do hope people got some value out of my presentation. And please feel free to reach out just to talk about whatever, or
Yeah.